Okay, so what we're basically going to do, in the past, I mean, before our break, right, before Thanksgiving break, we were talking about factoring, right? Remember that? We talked about factoring out the greatest common factor, right? You guys remember this, Isla? If I said 2x to the fourth plus 8x squared, what would I do?
You would do like terms combine them.
I'm factoring out. What is a common factor between 2 and 8? 2.
Oh,
What's
right.
a common factor between x to the fourth and x squared? X squared. And so when I factor it out, dividing this by 2x squared, the 2's cross out, and I got x squared, right? 4 minus 2 plus 4, right? And the x squareds cross out, right? So that's factoring out your greatest common factor. You always try to do that first. With all the factoring that we're going to be moving into, that's the very first thing you try, is factoring out the greatest common factor, okay? And, but we're actually moving now into quadratics, into parabolas, okay? Which is a huge field in algebra, and it's really important. This is the stuff that most people that take algebra, after a full year, they just barely touch it, and they don't really know it very well. So my hope is that because we still have a good 2/3 of the year left, you guys are going to know it so well that it's you'll just be so much further ahead. I just have to be sure that's not anything I need to see. Anyways, so we're going to talk about it, and this is actually one of my favorite parts of algebra. It's really, really fun stuff, and I think it's fun. Do you guys remember FOIL?
Oh, yeah.
So, well, actually, before I even go there, let me just show you what is a quadratic trinomial. What does it look like? All right, it looks like this. Ax squared plus bx plus c. A is a number, b is a number, and c is a number. So today, though, we are going to focus on quadratic trinomials. Notice it's a trinomial, right? Y'all see that? And a is going to equal 1. All right? So when you see a problem, it might look like this. X squared plus 2x plus 1. Something like that. Are you guys focusing on math, or what are you talking about? What are you talking about? Okay. So this is the kind of thing you're going to see, and we're basically going to want to factor it. And factoring it is going to look like this. And you'll have something here like an x and an x, and you might have something like this. That's how it might look. Okay? That actually is the factored version of this, but we're going to get there. So what I want to show you right now is let's go back to FOIL for a second. Make sure this is on here. FOIL. What does FOIL stand for again?
First, outside, inside, left.
Yes, excellent. And now let's say I gave you this. X plus 2 times x plus 4. How would I FOIL that out? I do first, right? Yeah, so I'm going to do the first to the first, and then outside, and then inside, and then last, right? Don't you agree with me?
Yeah.
Right, so my first is x times x. What's that?
X squared.
X squared. Okay, my outside is x times 4.
4x.
Okay, and it's positive, right? My inside,
2x.
plus 2x. And my last,
8.
plus 8. And what can I do with these?
Combine them.
Combine them, so I have x squared
Plus 6x.
plus 6x
Plus 8.
plus 8. Okay. This is the factored version up here. This is the quadratic trinomial. We know how to go from here to here, right? Our goal now is to go from here back to here. Okay? Really, really powerful. Really powerful.
Then why do we do it?
What? I'm sorry?
Then why do we do that if we're trying to go back to the first step?
Oh, well, that's a good question. That's a good question. Why would you do that? Because there are times when you, well, like in real life examples, I can show you, but I can't show you yet.
Okay.
You're just gonna have to trust me. I can show you once we get into word problems. I can't do the word problems until you understand the concepts, right? But once you see the word problems, you'll realize there are times when you need to bring it out so that you can combine like terms, and then you try to factor it back. And it won't be the same thing because you had to combine other stuff as well, okay? So just trust me on that for now. So can anybody look at these, look at this, x plus 2 times x plus 4. Do you see anything that you could use to create this? Do you see any similarities in that to this? Look at the 2 and the 4. How can the 2 and the 4 be used to get these two numbers?
They can both go into them.
Say what?
They can both go into them.
Well, okay. So,
What if you put the, like, if you just put the parentheses in between the 6 and the 8? But that wouldn't bring you back. Never mind.
no, well, I mean, no, you're thinking, that's good, that's really good. But, okay, so how could I use 2 and 4 to get 8?
Multiplication.
I could multiply them, right? So, but how could I use 2 and 4 to get 6?
2 plus 2 is 4.
Isla, you know. How can I use 2 and 4 to get 6?
Wait, what?
What could I do to 2 and 4 to get 6?
Adam!
Adam, right?
Oh, so long.
Right?
Yeah.
Okay, so interesting. So what we're looking for is, now notice, my 8 is my C. Do you guys see that? My 6 is my B,
I got it.
right? And my hidden 1 is my A. Do you see that?
Oh, no, it's kind of
Right? Okay, and so this is what I'm looking for. This is what I'm looking for. I'm looking for this. This is technically the way I would normally say it, but so I'll write it this way and then I'll explain it. Factors of C that add to B. Okay, factors of C that add to B. Okay, what are factors? Factors.
Stuff that multiply together to equal the sum. I don't know.
Yeah, two numbers that multiply together to get C, but that add together to get B. So immediately when I see this trinomial right here, and I see my C, the first thing I do is I write my C over here, my 8, right? And I'm thinking of factors of 8 that add to 6.
I get it.
Well, 2 times 4 is 8, and 2 plus 4 is 6. Therefore, I can immediately do this. X plus 2 times x plus 4. And I'm done.
Oh, that
I'm
makes
done.
sense.
Does that make see
Yeah.
the cool trick there?
Wait, so we
All right.
converted it, they converted it back?
Oh my god.
So we converted it back to this by using this trick right here.
Wait, why do we need to convert it back to that?
Factoring with quadratics is the key to solving everything with quadratics, and you'll understand that more as we get there. Right now, we just have to learn the skills, right? And then you'll understand why these skills are useful. All right, so let's try a few. Let's see, I'll leave that up for now. Okay, so that was number 1. So here's number 2. Okay, let's say I had x squared plus 8x plus 15. All right. Right? So here we go. I have a trinomial. A is 1, right? And I'm looking, my C is 15 and my B is 8. I'm looking for two numbers. So I'm going to write my C right here off to the side. And I'm going to figure out two numbers that multiply to get 15. 3 and 5?
Yeah.
3 times 5, what is 3 plus 5?
8.
8! Oh my god. So immediately you can just do x. Notice that's a positive 3 and that's a positive 5 because it doesn't have a negative in front of it. So I do x plus 3 and x plus 5. And you can always double check it. It's so easy. we know 3 times 5 is 15, right?
Yeah.
We know our b has to be our outside plus our inside. 5x plus 3x is 8x, right? Do you see that? 5x plus 3x is 8x, or 5 plus 3 is 8. Yes? You see that?
Yeah.
Okay. So those are the easiest ones that I can give you. All right, now we're going to make it slightly harder. All right, I'm going to move, well here, I'll do this. I'll do it right here. 3. What if I gave you this? X squared minus 4x plus 4. So I'm looking for, here's my c. I'm going to write my c over here. And I'm going to put my 4. Factors of 4 that add to negative 4.
2 and negative
2.
And negative
2. Negative 2. What?
2
Oh, that
times
would be 0.
negative 2 gives me negative 4.
Yeah. That'll
You
be,
just
2 plus 2 times 2.
that was just 2.
2 times 2 would give me
We're
4.
doing 4, not
Yeah.
But
half.
2 times negative 2 gives me negative 4. What?
Negative 2 times negative 2.
Oh!
Or just 2 times 2.
Oh, yes. That's right. Right. Does that make sense? I've got it in order to have that positive, both these signs have to be the same. They have to either both be positive or both be negative, right? Don't you agree with me? For that C to be positive, does that make sense?
Yeah.
Right?
Yeah, I understand.
So, and now what's negative 2 plus negative 2? Do. That's
4.
great. X minus 2 times x minus 2, right? We're done. Isn't that cool? It's easy. It's easy, and it's really fun. I think that's yours.
Is this it? Is there another step?
So wait, so we're gonna keep going. Let's get rid of all this. This board is starting to not work good. Okay, so 3, 4. Let's try 4. Let's try a couple more. How about x squared minus, how about, okay, here we go. Caleb, help me. What's the first step I would do?
You do the tree factor.
Okay, so I go over to my C, that's 12. And so I can start listing, guys. Shh. I can start listing if I don't know. 1 times 12, 2 times 6, 3 times 4. Do any of those add up to 7 or negative 7?
Negative 3 and
Ah,
negative
so
4.
right, for it to be negative, they just have to both be negative, right? That's positive, therefore this times this is positive 12. So immediately you've got x minus 3, and you've got x minus 4. Easy, right?
Yeah, I get it.
All right,
Can we get the homework?
now we're going to the hardest ones, okay?
Ah.
There is one other style that are hard. But let's just review real quickly, and so that we can see it. This has both positives, right?
Yeah.
If the C is positive, both of these signs have to be identical, right?
Yeah.
Right? Even in these, right? Both of these signs have to be identical, right? Here, right? If the C is positive, just makes sense, because positive times positive is positive, negative times negative is positive. If the sign here is negative, this one, right? You hear me? Caleb, you seeing this? If that sign is well, I'll say positive first. If it's positive, then both of these have to be positive. If this is negative, then both of these would have to be negative. So see, this says they're both the same sign. This positive here. This says they're both negative. Otherwise, there wouldn't be any negatives, right? Make sense?
Yeah.
You with me? Okay. Now, what about if I gave you this scenario? These are the hardest. They're not that hard, but they are harder, okay? You guys are writing all this down for sure?
Yeah.
Okay, so x squared minus 2x minus 48. Can you see okay?
Oh,
All right.
5?
So immediately, let me just get rid of this for now. So we've got negative, now notice C is it positive or negative?
Negative.
So when you write your C over here, you've got to write it with a negative. And you've got to think, what are your possibilities? One of them has to be negative, and one of them has to be positive. Don't you agree with me?
Yeah.
In order for that to be negative? So they're going to be different signs, okay? So I could do 1 times 48, but that would give me positive. So I could do negative 1. I'm gonna do the long version first, right? And then just so you see what I'm doing. I could do negative 1 times 48, or I could do 1 times negative 48, right? I could do negative 2 times 24, or I could do 2 times negative 24. You with me? I could do, isn't 3 times 16 48? I could do negative 3 times 16, or I could do 3 times negative 16, right? Or I could do negative 4 times 12, or I could do 4 times negative 12, right?
Can we tell them to turn it down too?
No.
It's not loud at all. Sounds like
Um,
it's gonna be like.
All right, or I could do negative 6 times 8, or I could do positive 6 times negative 8. See, those are all my possibilities. Do you see that?
Yeah.
All right, so now we add them together. That would give me that would give me 47. This would give me negative 47. This would give me 22, negative 22.
Oh,
Which
the very
one's the
last
answer?
ones.
What's the answer? What?
The very last one.
This one?
Mm-hmm.
That would give me negative 2. Oh, that's what I want. You're right. I was thinking it was positive. All right, so it's x plus 6, x minus 8. X plus 6 times x minus 8. Now, are you going to do this?
No.
Probably not. If it were me, I would probably do this. I would say 48. I know it's negative, right? And I would say, okay, I'm not going to bother listing negatives and positives, right? I might just say, okay, well, like I know 2 times 24, maybe, 4 times 12, 6 times 8. And I'm going to immediately see that one of them has to be negative, right? And if I make this one negative, I can see I'll get negative 2. To me, that's pretty easy, right? You see what I'm saying?
Yeah.
So I'm just going to immediately make that negative, and that gives me negative 2. Right? And so then that's my answer. Sorry. That's negative. Sorry, what am I doing? 6 minus 8, right, is negative 2. So, what was I going to say? So when when C is negative, let's think about this for a second. When C is negative, I almost think I should write this down. So when C is negative, the factors are opposite signs, right? Opposite is a 2 P's, opposite. It's 1 P, right? Does that look right?
No, it's
2 P's. The opposite are the factors are opposite signs. Okay? Right? Does it make sense?
Yep.
Okay, now this is the other key. This is the shortcut. When the first sign is negative, the bigger number is going to be negative. When this is negative, the bigger number has to be negative. That's the only way you get a negative. Otherwise, it's going to be positive when you add them together. Right? So, if first sign is negative, what's so funny? The bigger factor is negative. Doesn't look like a G, but that's a G. Is negative, right? Does that make sense?
Yep.
So let's try a few of those. Let's just see if we can master these now. So we're at 5, we're at 6 now. Okay. So here we go, 6. We're doing good. So 6. So x squared plus 14x minus 32. My c is negative, right? Negative 32. Factors of 32. What are all the possibilities you can think of?
1 and 32.
1 and 32,
1 negative.
8 and 4.
But one of them has to be negative though, because negative.
Yeah. They do. But I'm just trying to get what two numbers multiplied get 32 first.
Okay.
And then I will figure out which one I'm going to make negative. Does that make sense?
Mhm.
That's sort of the shortcut.
2 and 16.
2 and 16. All right. Well, let's just go with those. If I make, in order for this number, this first sign to be positive, in order for b to be positive, I know the bigger number has to be positive. So that's positive, that's negative. Bigger number has to be positive, that's negative. Bigger number has to be positive, that's negative. Do any of those add up to 14?
16 negative 2.
Yeah, we're done. X minus 2 times x plus 16. Because that equals 14. Does that make sense? Yes? Okay.
Yes, sir.
7. Let's try another one. How about x squared minus x squared minus 4x minus 45. What would it be? Negative 45.
Negative 45.
What are all the ways I can get negative 45? 3 times 15, I think. One of them's got to be negative. Since the first sign is negative, I know the bigger number has to be negative. 4, how about 5 times 9? The bigger number has to be negative. You with me?
Mhm.
Do either of those add up to 4, negative 4?
Yeah, I think that's the bottom.
Okay, so we're done. X plus 5 times x minus 9. Okay? Just a 5? Do you guys feel you get it? Awesome. Okay. Do you guys want to do a few up here first, or do you want me to just go? Okay.